Welcome back to the Gearland, guys. We're just continuing on our Mesa Boogie Mark II C Plus repair. We're changing out the filter caps. One section takes two of these 220 microfarad caps that run on 300 volt, and then the rest of them, about 5 total, run on the 300 microfarad 500 volt DC. And Tuck's just working on it right now, so let's just dive right in. So Tuck's heating up the lead to remove these caps, and he's got a, what'd you call that, a
solder sucker?
Solder sucker?
Yeah. Just pulls it off after you get it melted.
Nice handy tool.
Yeah, these things are great. Alrighty.
Pulling out the 30 microfarad caps now. Tuck was actually telling us a story where he was working on a Marshall on some capacitors. Were they filter caps, Tuck?
Yeah.
So he was working on some filter caps in an old Marshall, and I guess it was just one of those days where he was resting his hands on the chassis and his fingers accidentally got on the current of the capacitor. Current went through one arm to the other through his heart, and he was sitting for an hour convulsing with his
Bad day.
teeth chattering together.
That's why it's always a good idea to discharge everything before you start doing any soldering on one. That's what I was doing with that tool I just showed you. This right here.
Yep.
Clip it to the chassis. Go through all the places that have DC on them, and this will drain all the voltage off before you start touching anything.
It returns it back to ground?
Yeah.
Cool.
Just got a 100 ohm resistor in here to make it where it doesn't arc, you know.
Mm-hmm. The spark won't give an arc?
Yeah, it slowly drains it.
Oh.
Instead of just shorting it out, that burns the board up when you do that.
And that lead part, that's called the solder, right?
That's solder, yeah.
Okay.
It's silver and lead mixture.
Silver's a good conductor for
Yeah,
electricity.
it's great.
A lot of nice instrument cables are made from silver coating.
Seymour Duncan actually is making some pickups that are using silver wire. I haven't heard a set of them yet, but they're very expensive.
How much are they going for?
I'm not sure. I think they're around $400 a piece for the pickups.
Whoa.
So, yeah.
That's a little intense.
And
one of them costs as much as a
I can't
Squire.
see that being a big seller for them. Can you?
You know, in today's market, I could actually see it doing pretty well.
Really?
Because someone out there is willing to get a set of pickups for 800 bucks.
And you see this, when they blow up like that, you can tell they're usually bad. But these are all probably, how old, 20 years old?
I mean, if it was 1984 when this amp was made,
Oh yeah.
That's almost
40 years old.
nearly 40.
Yeah.
Let's you just try to open one of these up real quick. Nothing that special. Maybe it was just the tape got hot.
Yeah, it's just
I
hot.
bet you can feel it though. Like, can you run your finger over it and feel that the case is bulged?
Actually, no, not at all.
It feels.
Tuck, by mixing the 30 microfarad with the 220 microfarad at the different voltages, what's that doing to the signal?
It's not doing anything to the signal. These are not signal caps. These are just power supply caps.
For the transformer?
All they do is go from the transformer to supply the voltages to the tubes, the different voltages. These two here are not put in parallel like these are. In parallel is, you know, each one's hooked up like speakers are.
Mm-hmm.
These are hooked up in series. So one is connected to the end of the other one.
Okay.
Both ends are connected right here, and that doubles the capacitance
Sure.
and the voltage.
Yeah.
Doubles your voltage and cuts your capacitance in half. That's why this had to be bigger than these,
Mm-hmm.
because when you put these in series, they cut that in. You got two of them and cut it in half. So instead of 220, we've actually got 110 with these two together,
Yeah.
and double the voltage. It'll handle almost 700 volts now.
Nice.
These are the two that get hit by the voltage when you first flip the amp on,
Mm-hmm.
and it takes that extra amount of voltage out of the amp, you know,
Sure.
where it doesn't tear it up. If you just hit these with all that voltage at one time, you'd pop one every now and then.
So when it runs in series, it's getting like the negative
It'll handle
current,
double the voltage.
and then like one side's negative and one side's positive. So does the positive side hit the? Does the positive wave hit the?
The negative side of this right here
Yeah.
is coming from the transformer. It goes through the other one to the positive, and then it'll go to these. It'll go to each one of these. Each one of these will go to two of these tubes.
Okay. 2 of the 12AX7s.
Yeah.
Okay.
You got resistors in between each of these, so that it drops the voltage down each step. It starts out at 450 volts, and the time it gets down through all these, it's down to around 190 volts to run the first tube.
Okay. And
Your output tube that goes straight off the transformer, they're not dropped at all.
there's just AC straight to the
It's
output.
DC, but like everything else, but it's not dropped down any. It's not stepped down any. It's the same voltage that's coming out of the transformer. It's going straight to these two tubes.
So it's getting 120.
No, it's not. That's not the voltage you're getting after you rectify it.
Oh, okay.
That's a secondary voltage is what you're getting here. It's 450 volts.
Per out
This
per
is the
6L6.
This is the second side of the transformer. It goes 117 into it,
Yeah.
but the output of that, which is going to these
Mm-hmm.
and these, is 450. So
Okay.
it starts out at 450 volts DC, and it steps down gradually as it goes to the smaller tubes.
So the first cap gets the 450.
Yeah, these. Yep. These are
Okay.
the first ones that get hit.
Okay.
It gets the whole 450.
The 30 or the 220 microfarad combined.
Yeah. It makes 110 microfarad.
Okay.
And it'll handle double the voltage.
600 volts.
Yeah.
Okay.
So it's quite a bit of voltage handling capability, you know. That's
Yeah,
the
yeah.
reason they got those big caps in there.
I mean, those output tubes, are those like the component that require the most voltage out of anything on the amp?
Yeah, absolutely.
Okay.
Yeah.
Cool.
Yeah, they take the whole voltage straight out of the transformer.
That's cool.
It goes through the diodes and then straight to these tubes.
Well, maybe in the Mesa Boogie, Mark II C Plus in particular, maybe that voltage is like really cooking those power tubes to maybe we're hearing the transformer in the power tubes. So that might be like part of the reason this thing has the magic that it has, right?
Maybe.
Because a lot of people say that this 105 model transformer gives the Mark II C Plus the bulk of its like quote unquote three-dimensional tone.
I would think that the output transformer would be more involved in the tone.
Oh yeah, yeah. I see what that's. I see.
The output transformer is what pushes the speaker.
Yeah,
You
yeah,
know,
yeah.
it-
I'm jumping ahead
Yeah.
myself.
Okay. This transformer here, all it does is supply the DC voltages to run everything. It doesn't have anything to do with your tone at all.
Mm.
Is it possible, Tuck, to give us a real quick lesson on why the step up to 450 volts? What's the
Why?
result if you try to accomplish that same thing with 110 volts?
All the tubes won't even run.
Is it because it's just not possible to make a tube that could get the job done at 110, or would it be too noisy even if you could do it?
Well, they didn't have the technology when these tubes were developed.
Okay,
The 6L6 was made back in
right.
about the 40s, I'd say.
So it's more that the engineers just said this is the best we can do.
Yeah.
By the way, you need to give this 450 volts.
And as far as I know,
We can't get it
I
to
may
work
be
any
wrong.
lower.
I may be wrong, but all output tubes still require high voltage.
Yeah.
I mean, all of them.
So there must be some fundamental reason
Yeah.
why, when you try to do it at lower voltages, you just
Solid
can't
state
get it done.
devices will do it.
Yeah.
That's if you want to run things at 9 volts DC
Yeah.
off a battery.
Yeah.
You're gonna go solid state. You don't want tubes in there.
Yeah.
When you get involved tubes, you're gonna involve high
You're
voltages.
always talking high voltage
Yeah.
every time. No, it's
Every-
not like one guy figured out how to do it at lower.
No, you can look through the RCA tube manual.
Yeah.
Every one in there
Yeah.
runs at least 400 volts on the output type
Okay.
tube. You know,
So it's
some
just-
of them run even higher.
Yeah.
You know, 500 and 600 volt.
Yeah.
But there's a lot of magic in that high voltage.
Well,
It's got a better sound to it, I think.
doesn't the voltage result in like the signal enhancing even more? Like it's creating more amplitude after the power section, so it actually literally creates a bigger wave before it hits the output transformer. Like the wave is actually smaller before it hits
You
the,
know, it
the
grows.
600 volts.
It starts going from your first tube
Mhm.
right here from the input jack, and every step, every tube you check the output of that tube, the signal will be a little bigger until you get to the phase inverter, which feeds these two tubes. It sends half the signal to this one, half the signal to that one.
Feeds the power section.
Yeah.
Okay.
It's called a phase inverter. And
So you're getting literally left and right with these tubes then, in a certain way.
it's running you how the output on the the schematic shows three wires.
Okay.
Well, you got a left and right output and a center where the voltage hits. Well, it takes voltage in on the left and the right, and then it comes out of that, and it's got a ground and a hot on the secondary part of the transformer.
Okay.
So that's how it works. You have to have a left and right input to the transformer on an AB. This is an AB type amp.
And we're talking left and right for the output transformer, right?
Yeah.
Okay. Cool.
But it comes out mono. The output of the transformer is mono. You just have to have a left and right into it.
Oh, okay. Yeah. It's one wave.
It's push-pull is what they actually call it. They don't call it stereo. You know, one tube's pushing while the other's pulling. So you get up, the sine wave goes up, and then the other tube turns on and it pushes it the other direction. It goes down. That's how you get a sine wave.
It's each of them are taking
Half.
care of one half of the wave.
Yep, and they go on and off the whole time that the amp's running. As the signal goes through here, one tube will turn on, the other one turn off, turn on and off. They can go on and off just like that all the time.
So the only way to get stereo on these tube amps is to run two separate output transformers.
Exactly. Which some of them old Gibsons were stereo, you know. I've had some in here.
Interesting. Gibson of all companies.
Yeah. Yeah, that was pretty popular back in the 50s. You know, they made a lot of stereo amps.
And essentially, yeah, it's just 2 amps, right?
That's all it is, just left and right.
Yeah. that's just a silver cap, huh?
Yeah. Okay.
I don't really want to take a guess on what that is, but
That's your diodes.
that's what I was gonna say, actually.
That's what turns this AC into DC.
Oh, so rather than a rectifier section, we
See
got
this
a diode.
right here? This is the output section, the 450 volts. Right here it is.
Okay.
It goes straight to these diodes, which turns it into DC instead of AC. And then it hits these caps.
Mm-hmm.
After you hit these caps all the way through the amp, the rest of the way it stays DC. The only AC you got in here is the heater voltage. That's 6.3 volts. It runs the heaters on all the tubes.
So it's running like the cathode? It's heating a cathode on the tubes?
No, it's heating the heaters.
Okay. I thought the heaters...
See where it says 6.3?
Yep, right here.
Yep. The cathode on your tube is actually the input.
Mm-hmm.
It's not the heater. The heater is just like the part of a light bulb that lights up. That's what it looks like. It looks just like a light bulb.
The filament?
That's all it is filaments. It just heats that tube up.
Okay. Because I guess I got that confused with like heating the cathode plate.
Yeah, that's a totally different voltage. That's a lot higher voltage you're talking about there. Alright. Now, where's my tubes at? I don't know.
You got
Caps.
even more under this filter cap section right here, this 50 UF,
That goes to your bias.
50 microfarad for the biased.
Yeah. You know, you got minus 52 volts going to these two. And these right here are the ones that, these two diodes here, take that 56 volts and turn it into DC after it goes through these rectifiers. Then it goes to these to keep from, that keeps all your hum out.
Okay.
This thing would hum terrible if it didn't have these caps, you know.
Go to school and get licensed.
One's
They
positive,
are
one's negative.
directional.
You sure are. And they will blow up. You put them in backwards. Looks like we got her, guys.
She's all soldered up. It's a doghouse without a lid.
Yep. I like how them old fenders had the doghouse with everything enclosed. It was nice, wasn't it?
Yeah, I do like that. Boogie should have taken some notes from that.
They were able to make their amps smaller though, because they didn't use that. So,
Oh, yeah, that's true.
and using the PC boards, they got all that wire everywhere. I like that too. You know, all this would have been hand wired if it was Fender, instead of having all the traces on here. Let's hook a speaker to this and make sure this works before we go any further.
All right. So this is how you test the DC voltage.
See what we got here? 447.
Let's show these guys the meter.
And it ain't all the way up.
Right. So you're just making sure that we're seeing 450
Right.
everywhere we should.
Yep. Now, I know these are in there right. If that one of them was around the wrong way,
Yeah.
it would have been showing short as I brought the voltage up. That's
Yeah.
called a variation.